Hello and welcome to my project, Dependency Management and Software Projects. My name is Kristen Stone and this is CS5704. Before we get too in-depth of dependency management, let's discuss what dependencies actually are. In software engineering, dependencies refer to external components or libraries that a software project needs in order to function properly. These dependencies can be other software packages, frameworks, or modules that your code relies on to perform certain tasks or to provide specific functionality. Therefore, dependency management in software engineering refers to the process of handling the dependencies, libraries, frameworks, tools, APIs, etc., that a software project relies on to function correctly. It involves managing how these dependencies are added, updated, and resolved to ensure that the software runs as expected, is maintainable, and doesn't encounter issues such as version conflicts or missing dependencies. These dependencies are typically managed through build tools, which automatically download and integrate the necessary libraries into the project. Take a look at the picture here. These are all different tools within the software engineering lifecycle. Today, we will be discussing specifically Maven versus Gradle, which are two very popular, very powerful build tools. Within this picture, take a moment to look at all the different options for different stages. Can you find Maven and Gradle hidden anywhere? So, why is dependency management important? There are many reasons, but let's discuss a few. First, it ensures stability and compatibility with version control and conflict resolution. By explicitly managing dependencies in their versions, you can ensure that your project behaves the same way across different environments. Without proper dependency management, different developers or servers might run different versions of the same libraries, leading to unexpected behavior and bugs. Second, libraries and frameworks often release new versions that can introduce changes. Proper dependency management helps to lock the required versions of libraries, preventing unexpected issues when new versions are released. Then there's the aspect of reusability. One of the core principles of software engineering is not reinventing the wheel. Reusability allows developers to leverage existing libraries or components, saving development time and effort. By using popular and maintained libraries, developers don't have to worry about writing, testing, and maintaining common functionality. And finally, there's automation. Automation reduces the manual effort required to add, update, and manage libraries. Tools like NPM, pip, Maven, and Composure automate tasks like downloading libraries, integrating them into your project, and handling updates. This minimizes human error and speeds up the development process. So now that we know what dependencies and dependency management are, let's talk about Maven and Gradle. As stated before, Maven is a powerful build automation tool commonly used in Java projects. It simplifies the software development process by automating tasks such as compiling code, running tests, packaging, and managing dependencies. Maven operates with a declarative approach where you specify what you want to achieve in a configuration file called pom.xml. While this file uses XML and can be a bit complex, it clearly defines the structure of your project. One of Maven's most useful features is dependency management, which allows it to automatically download the necessary libraries from a central repository, ensuring that your project always uses the correct versions of those libraries. In short, Maven streamlines the build process, making it more efficient and less error-prone. Gradle is another powerful build automation tool known for its flexibility in building software. It's used for languages like Java, Android, C, C++, Kotlin, and Groovy, and handles tasks such as compiling, linking, and packaging code. What sets Gradle apart is its combination of imperative and declarative approaches, allowing you not to just declare what should be done, but also to specify how you do it in a more customized way. This makes it highly flexible and adaptable to various project needs. Gradle is also optimized for faster builds, especially with larger projects, which can significantly improve productivity. Its dependency management system is very powerful, capable of downloading dependencies from repositories like Maven and resolving conflicts efficiently. In short, Gradle offers flexibility, speed, and customization, making it a great choice for complex and varied software projects. Here's a simple chart on how Maven and Gradle differ from each other. First, let's talk about configuration. Gradle uses Groovy, which provides more flexibility and customization, while Maven uses XML, which follows strict conventions. This makes Gradle more adaptable and allows developers to tailor the build process to their needs, whereas Maven is a little bit more rigid. When it comes to performance, Gradle is optimized for faster builds, especially with larger projects, thanks to features like incremental builds. Maven tends to have a slower performance, particularly as project size grows. In terms of language support, Gradle is versatile and can be used with a variety of languages like Java, Python, C++, and more. Maven, however, is mostly designed for Java projects. Both tools handle transitive dependencies, but Gradle does more so efficiently and is better suited for managing complex dependency graphs. Lastly, Gradle gives you greater control and the ability to customize your builds extensively, while Maven is more limited in terms of customization. Maven and Gradle each have their own set of advantages and disadvantages. Maven is known for its convention over configuration approach, which simplifies the setup by following strict conventions. It has a large ecosystem, is stable and mature, and offers easy dependency management. However, Maven comes with some downsides. Its XML-based configuration can be verbose, it tends to have slower performance, and it offers less flexibility and fewer modern features compared to Gradle. Now, on the other hand, Gradle is praised for its faster builds and flexibility, allowing developers to customize their builds using Groovy or Kotlin DSL. It supports incremental builds and multi-project builds and offers good dependency management. The trade-offs, however, include complexity, a steeper learning curve, and a smaller ecosystem compared to Maven. Additionally, Gradle is less convention-based, requiring more effort to configure compared to Maven's standardization. In summary, Maven is a great choice for projects that value stability and simplicity, especially with Java, while Gradle excels in performance, flexibility, and support for more complex, multi-language, and multi-project environments. When deciding between using Maven or Gradle, it really depends on the type of project you're working on. Maven is ideal for stable, long-term projects where simplicity and reliability are key. If you have a simple project or need compatibility with existing tools, Maven's mature ecosystem and less complex configuration make it a great choice. It's perfect for projects that don't require heavy customization and where sticking to conventional practices is more important than flexibility. On the other hand, Gradle shines for performance-intensive projects or projects that require a high degree of flexibility. If you're working with modern development practices, need cutting-edge features, or developing for Android, Gradle is the better option. It also excels in scenarios where you need to manage multi-project builds or complex build processes, offering more control and customization. So, my suggestion is use Maven for stable, simple, and conventional projects, and turn to Gradle for more complex, performance-driven projects that demand flexibility and modern features. Hopefully this project helped clarify the key differences between Maven and Gradle, as well as provide structure on what dependency management really is and why it's so important. Now for one last question for you. Which one will you decide to use?